Hello friends, I am Agrawal, Assistant Professor in Civil Department, Sandipani Technical Campus, Latur. Today's topic is influence line diagram for internal forces of 3-inch parabolic arch. Learning outcomes. After watching this video, student will be able to understand the concept of ILD, and also student will be able to draw ILD for internal forces of 3-inch parabolic arch. ILD for normal thrust. Now, how this normal thrust? Suppose this is an arch. Suppose this is a parabolic arch having a span L and rise is the H. Now suppose at any point P, suppose if you want to find the internal forces at here, if you take the free body diagram of this total part, suppose this part here, suppose so here the forces are like this. Suppose here is a vertical reactions VA, horizontal reaction is the H. So here is the horizontal reaction H. Then here is a vertical force is V, and here this is having the normal thrust is like this, is called as N, and is having the radial shear like this, that we call as a Q. So this is theta and this theta are the same. So here how to write the equation? First we write the equation of this normal thrust. So that equation is N is equal to, now we are resolving this H and this V along the N. So if you resolve this V along the N, that becomes the, here is one horizontal force and one the vertical force. So this is the, becomes V sine theta, and this direction and this direction is the same, that is why it's a plus. So V sine theta, and again you have to resolve this force, this H force along with the N. So this is the resolution of this force is like this, is 1, and like this is vertical. So this is called as H cos theta, and this is the H sin theta. So this force is again the, this direction is the towards the left, this also towards the left, that is why it's plus H cos theta. So here this is the equation of the normal thrust. Once we got the equation, then we draw the ILD. Now here, how to draw the ILD for this normal thrust? So now we know that here this V is the vertical shear force, and this H that we know is the horizontal reaction or thrust, horizontal thrust. So first we draw the ILD for this part V, and we multiply it by this sin theta. So here we know this is our, suppose this parabolic arch like this. This is a 3-inch arch, 3-inch parabolic arch, Now for that we have to, for any type of the ILD we have to apply the unit load. This is 1 and this is the X, this height is the H and this length is the L. Now here, for the sake of convenience, now we are drawing here, this is considered as the simply supported beam. This is the VA. This VA is also the same here, VA. This is the VB and here is a VB. So here this is the unit load which is moving from left to right throughout the span. And suppose anywhere we want this at, suppose is P, suppose this distance is the, suppose is a Z, where we want the internal forces. Now here at this P we want the normal thrust, this N. So first we draw the ILD for this V, the vertical shear force. So now we know this, suppose this point is the, this P and this distance is the J. So these reactions become the X by L and these reactions become the 1 minus X by L. So ILD for this shear force, this V, which is V, this vertical shear force V. So we are drawing the ILD first for this vertical shear force V as like a beam, So we know that here this ILD is the like this. At this point P, we have to draw a vertical line, then join this here and then join this. This part is plus, this part is minus. This we know is a Z by L. This is a 1 minus Z by L. This already we have seen in the previous lectures. Now, but here, this is the ILD for V. ILD for the V. But what here? We want this ILD for V sin theta. So here, we are multiplying this. We are multiplying this a quantity, or we are drawing it some safe. This diagram is like this. This is the 1 minus Z by L and this is the Z by L. This minus and this is the plus. So now this distance is the Z and this distance is the L minus the Z. So multiply here by the sin theta. Multiply here by the sin theta. Sin theta here also and sin theta here also. So automatically this ILD becomes for this V sin theta. So here we can say that this is the ILD for V sin theta. So in this way we got the ILD for this V sin theta. This part is minus and this part is the plus. The distance is Z and this is L minus Z. So this is the ILD for this V sin theta. Now we draw the ILD for the, again, first for the V, then multiplied by cos theta. So that ILD becomes the H cos theta and then we superimpose both this diagram. So now, in the previous lecture we have seen that this ILD for the H. ILD for the H. The ILD is like this. At the center, and this height is the L by 4h. This is the L by 2 and this is the L by 2. Now this is the ILD for h. Now for the ILD for h cos theta. We want the ILD for this h cos theta. So multiply this ordinate with the h cos theta. So this becomes like this, suppose. So we modify this ILD like this. At center, here is a L by 4h. So multiply here by the cos theta. So this becomes the ILD for h cos theta. This distance is the L by 2 and this distance is again the L by 2. Now this is the ILD for h cos theta and this is the ILD for the v sin theta. Now superimpose both this diagram. Now this part is the positive here. What is the formula? You have to add these two quantity. Now this is a plus. This h cos theta is a plus. So now we can say that this quantity is a plus. And here this quantity is again the plus. So we cannot add this over. So invert this diagram. Invert this ILD. Now here, what is here? Invert the ILD of b sin theta. First we invert that diagram. So here this plus is above the line and this minus is above the line and plus is the below the line. So we can say that here, first we draw here the invert this diagram. The ordinate is the same, that is the Z by L into sin theta. This is the 1 minus Z by L into the sin theta, and this is the plus, and this is the Z by L sin theta, and this quantity is the minus. Now we can superimpose, pick up this diagram as it is. You have to pick up this diagram L by 4h into cos theta and put here, because this length is the L. This length is the L. Also here this length is the L. This total length, this is the L. So now superimpose here this plus over this minus. So this becomes like this, suppose. Like this. So this is L by 4h into cos theta. Cos theta? Yes, cos theta. Now this part is a plus, this part is a plus, and this part is a minus, and this minus is how much? Here, this ordinate is the Z by L into sin theta, this ordinate. So now this is our the final diagram. This hatching is our final diagram. So this is the ILD. This is the ILD for normal thrust or axial thrust, or somewhere this may be called as axial thrust. Then we draw the ILD for the radial shear. Now next is the ILD for radial shear. Now what is the formula for that is? That is the Q. Now how to develop that Q? Here, what 3-by diagram is at here? Now from here. This is the Q. Again we will resolve this V along with Q, and again resolve this H along with the Q. So now this is the downward considered as the positive. Now here, this downward considered as positive. So this point is what? V cos theta, this vertical force. Now this direction and the direction is same. So we can say that here the Q is equal to V cos theta. Then this is the vertical rotation. It is the opposite direction. Now this is the positive direction of the Q is the downward. This is upward. That is why it is called as minus H sin theta. So we got the equation of Q, V cos theta minus H sin theta. V cos theta minus H sin theta. V cos theta minus H sin theta. Now again the same procedure. We have to draw the ILD for this V, then multiplied by cos theta, again ILD for H and multiply by the sin theta. Now for this 3-inch arch, suppose this 3-inch arch parabolic is like this. This is the span L. This is the height is the H. For that we have to apply the unit load on this arch. This is 1. This is the X. This is the P point somewhere. This distance is again the Z. Now for our simplicity, now we are drawing here a beam simply supported, which is subjected to unit load. This is the X, and this distance is this point P where we want the internal force. This is a Z. This total is the L. Again we know this reaction is L by X by L, and this reaction is 1 minus X by L. So now we know the ILD for the shear force at point P as the previous same. That is the like this. At this point P, draw the vertical line where we want the ILD for the shear force. Again this is the minus and this is the plus. This is the 1 minus Z by L and this is a Z by L. So this is the ILD for V. This is the ILD for the V. Now, next we have to draw the here ILD for V cos theta. So we have to multiply this quantity by the cos theta. So this becomes like this. So here is 1 minus Z by L. So multiplied by the cos theta. This is a plus, this is minus, this is a Z by L multiplied by cos theta. So this becomes the ILD for the V cos theta. Now next is this ILD for this h sin theta. Now first we draw the ILD for the h sin theta, suppose here. Now ILD for the h that we know. This ILD for h is like this. At center, this height is the L by the 4h. Now here multiply by the sin theta. So here it becomes the sin theta. It becomes the sin theta. Now here, what is the formula? Here the formula is v cos theta minus this h sin theta. This sign is a minus. It means what? This quantity is a minus. So give this sign as the minus. Give this sign as a minus. Now superimpose both this ILD for the v cos theta over the ILD for the h sin theta. Now this is a plus and this is minus. So pick this diagram and keep it over the v cos theta. So now if you draw this diagram, it's like this, suppose. This is Z by L cos theta and this is the 1 minus Z by L into cos theta. This quantity is plus and this is the minus. So superimpose this quantity over here as it is. See, this distance is the L. This is the L by 2. This again is the L by 2. So suppose this is somewhere here, the center. So draw this quantity like this. And this part is the negative, this part is negative, this remaining part is the positive, and this height is the L by 4h into sin theta. This is the Z by L into cos theta, and this height is the 1 minus Z by L into cos theta. So this part is negative. This remaining part is positive, this is negative, and this total is the negative. So this is the ILD for radial shear. Thank you.